Hello and welcome to Lesson 5 of Interpreting Graphs of our Module 3 unit. In today's lesson, we are going to be talking about how to describe graphs. So for this lesson, you need 3 highlighters. So if you have not done so already, please go grab 3 highlighters because we're going to help see how we're going to color code things to kind of bring attention, kind of separate it, because we don't need a calculator for today's topic, but we are going to be describing graphs, looking at them, saying what's going on. All we really need to know is how to count on a coordinate plane. So we are going to start with x-intercept. So that's where we cross the x-axis. And so an x-intercept looks like x comma 0. Or you can write it, I will just take the x value. So here's your x-axis. Where do we cross the x-axis? There are 3 spots that we cross. Here, here, and here. Now I'm going to zoom in to kind of explain why my values are there. So it's where we cross our x-axis, and we go 1, 2, 3, 4. So this I'm going to say is at about negative 4.1. And then my next one I'm going to say is about negative 2.2. The reason I'm doing decimals is because we don't cross perfectly on a lattice point like this one right here is. And our last one, I'm just going to say it is 0.5. So we have 3 x-intercepts, and they are at negative 4.1, negative 2.2, and 0.5. Our y-intercept is where we cross the y-axis. So here's our y-axis. It's already labeled, but still it helps. This is where we are crossing the y-axis, and there will only ever be 1. And our point is always going to be 0, comma y, or I will just take y. Again, there's only ever going to be 1 y-intercept. And so our y-intercept is a nice lattice point. It is at negative 3. Okay, so those you probably maybe have talked about before, but the next topic we're going to see, this is why we really this is half of the reason why we have highlighters right now, is positive is when our graph lies above the x-axis. So here is our x-axis. We're going to highlight everything above it. So this is above it, and this is above it. What's kind of cool is that we're going to be using our x-intercepts for our positive and eventually our negative answers, because our x-intercepts, or you can think of it, are like a portal between your positive and negative. So we are positive from negative 4.1, comma, to negative 2.2. We're writing it as an interval. Then we're going to have a union symbol. What it does, it kind of tapes together our other positive interval. So that's from 0.5 to infinity. Now the reason it's infinity is because of that arrow. Okay, so that's our negative. Now what we're going to look at, that's positive. Negative is below the x-axis. So that's everything underneath the x-axis. And so because the arrow on the left side is going towards negative, it is an arrow, we're going to have negative infinity to negative 4.1 union, and then we are from negative 2.2 to 0.5. And that is x-intercepts, y-intercepts, positive, and negative. So for the next, I think, 3 problems, we're just going to practice these in different ways, different graphs. So x-intercepts, where we cross the x-axis. So we have it at negative 4 and positive 3. Again, we can write this as a point, negative 4, comma 0, and 3, comma 0. I will take either one. Our y-intercept, where we cross the y-axis, is negative 12. Again, we can write this as 0, comma negative 12. It's positive, so again, this is above the x-axis. So here and here. And so we are positive when we're from negative infinity to negative 4 and from 3 to infinity. And we are negative when we are below it right here. Now, this is from your book, so I don't like this. I'm going to cross it out. And we are negative from -4 to +3. Okay, there we go. So, going on to our next page, we're now going to actually write points because it's asking us for a point. Now, this one always causes a little bit of difficulty with the positive and negative. So, x-axis, where do we cross? At 1 point at 3, 0. Again, our y-intercept is asking for a point, and that is at 1, 2, 3, 4, 5, 6, 0, 6. Now, our function is positive above the x-axis, so everything here. And so we are positive from -infinity to 3 with the parenthesis. We are negative below it, so that's everything else. So from 3 to infinity. Okay, so now what we're going to do is we're going to talk about this in the context of a real life problem. So the graph shows the height of a ball for each second x that it is airborne. We're going to use the graph to estimate the x and y intercepts of the function, where the function is positive and negative, positive and negative, and interpret the meaning in the context of the situation. So our x-intercept, where it crosses the x-axis, is 9. So what this means is the ball will hit the ground after 9 seconds because x is time. Our y-intercept, where we cross the y-axis, is 4. And so our point is 0, 4. So what that means is that time 0 seconds, I'm going to put seconds, the ball was at a height of 4 feet because that's our y value. Now, the function is positive when x is between 0 and 9 because everything is above the x-axis, which means the ball is in the air for 9 seconds. Now, no portion of the graph is negative. The reason that nothing is negative is because the ball can't go back in time, and it can't go into the ground. What I mean by this is this right here, it can't go backwards. We can't go to negative time. And over here, we can't go into the ground, and so that's why there's no arrows on our graph. What we're going to do now is we're going to go on to the next page. We're going to do a really big problem, but it just steps it up and kind of brings in a real world problem with science, okay? So Violet starts the semester with $150 in her student lunch account. Each day she spends $3.75 on lunch. The table shows the function relating the amount of money remaining in her lunch account to the number of days Violet has purchased lunch. So what we're going to do in part A is we are going to find the x-intercept. So again, an x-intercept is where y is 0. So I'm going to go to y, find where it's 0. The x-intercept is 40. Now, our y-intercept is where x is 0. And the y-intercept is 150. Now, what this means in the context of the problem is the x-intercept means that after buying lunch for 40 days, Violet will have $0 left because an x-intercept, our x-intercept is 40, 0. And our x values is time, and our y values is the balance. Now, or it will take 40 days to use all of the money in her lunch account. The y-intercept means that Violet's lunch account has $150 after buying lunch for 0 days, because our y-intercept is 0, 150. And again, the x is time, the y is the balance. So, or you can think of it as meaning her balance in the account is 150. Now, it even says right here, Violet starts with $150. That's our y-intercept. So we can find the y-intercept in the problem, but we can also find it in the table. So now what we're going to do is we're just going to practice creating a graph for that table of information. So we have our X label, we have our Y label. So we have time, oopsies, let's fix that, time in days. And then our y-axis is, I forget, balance. That's what it says. We're going to use that. Balance in money. Now, we do need a scale. So we have to get to a 40. So I'm going to go by 5s. 20, 30, 40. Okay, and then my balance, I'm going to go by 20s. This would be 40, 80, 120, 140, 160, I think that's right. 20, 40, 60, 80, 100, 120. That's not right. Oopsies. I made a mistake. I knew something was wrong. Okay, so 120, this would be 160. There we go, because it's all multiples of 4. Okay, now we are missing a very important thing. We're forgetting a title. So I'm just going to say Violet's lunch money. Whoa, what happened there? Let's fix that. Money. There we go. Okay, so now usually you can plot all this, but for our class, for math class, I'm going to plot my y-intercept, which is 0, 150, my x-intercept, which is 40, 0, and then I'm just going to connect my points. Now, there are no arrows because we can't have negative, or we can't have, like, our balance can't be negative, and we can't go back in time because we can't have negative days. So that's why we have closed circles right here, and it stops there. So that's how increasing, decreasing, oopsies, that's on the next. That is positive, negative, x-intercepts, and y-intercepts. Now what we're going to do, the real reason we have 3 highlighters is right here. We're going to be adding on more ways to describe a graph. So, increasing, this is where your graph is going up. Decreasing, this is where your graph is going down. And constant, that is where your graph is plateauing, also known as it being flat. Now, we are going to only use our x values, and we're going to only use parentheses, which can be a little confusing. So, for this one, I want you to do everything I do, and then as you get more practice, you can slowly start to take things away that you're like, oh, you know what, I don't need the highlighting, or I don't need the dashed lines that you're going to see in a moment. So, what I'm going to do, again, I'm going to bring those colors down. So, increasing is going to be green for me. Please do add arrows to your graph right here. It's going to help. So increasing, that is where my graph is going to go. So what we do is read graphs left to right, just like you read a book. So what I'm going to do, I'm going to just watch my laser for a moment. This would be my highlighter. Wherever my highlighter eventually goes up, I'm going to highlight. So following it with my highlighter, I highlight here, and I highlight here. Then I'm going to do decreasing. That's where my graph goes down. So I'm going to do the same thing, but now I'm just going to highlight where it goes down. And then finally, constant. That is where my graph is flat. So what we're going to do now is we're going to draw in dashed lines where we changed colors towards the bottom. Now, as I go down, I'm going to see what x value I go through. So I go through -4. Oopsies, I missed a color. I go through -3, -2, and 1. And then I'm going to look at my endpoints and see, oh, my left side is going towards negative infinity because of the arrow. My right side is going towards positive infinity. Now, I'm going to bring my colors down. So like I was orange right here, I was blue over here, blue right here, and green right here. This is probably one of the first steps you're going to probably take away. I like doing it because all I have to do now is bring them over. So negative infinity to negative 4, that's blue. Then I'm orange from negative 4 to negative 3. And then I'm green from negative 3 to negative 2. I'm blue again from negative 2 to 1. And I'm green from 1 to infinity. What this does down here is it makes it so that way you don't have to worry about the order. You don't have to forget which one goes. All you have to do is write it down, like basically copy it over. The color coding, like the color coding of the actual graph, I would maybe keep doing for a while because it really helps find extrema. So there's two types of extrema that we're going to focus on right now. There's a couple others, but we're just going to focus on a relative maximum and a relative minimum. Okay? So a relative maximum, it's a point. And what it does is it goes from increasing to decreasing. It can only be that. So that's why the colors are nice. So my increasing to decreasing colors. So if I look at my graph, I can see, oh, increase to decrease. This right here, we use the word max for short, is at negative 2, 10. That is a maximum. A relative minimum is a point as well. And what it does is it goes from decreasing to increasing. So again, in my case, I would be going from blue to green. And so if I look at my graph, I see, oh, this point right here is a minimum at 1, 4. Those are my only relative extrema, or my extrema, because everywhere else, it does not go from green to blue or blue to green on my graph and using the colors I used. Okay, so what we're going to do is we're going to go to our last page. We're going to do one last problem together. It brings everything together. As you can tell, everything over here has been in all of our lessons at some point. So here we go. Is it a function? Yes. Passes the vertical line test. Our domain, left to right. Well, we have arrows going to the left and to the right, so it's negative infinity to infinity. Our range, the bottom of our graph to the top of our graph. So our range is bracket 1 to infinity. Again, if it's not clearly marked open, you're assuming it's closed. F of 3. That means we go to x equals 3, go to our graph. That y value is our output, our answer. Okay, now we're going to go to x equals 0. Go to our graph. That y value is 2. Okay, our next one, we're given the output, so y equals 2. I'm going to draw a line. Remember, the reason we do this is so we can see, oh, there's 2 inputs that give me that output at 0 and at 2. Now I'm going to bring in my color coordinating, so increasing where my graph goes up, decreasing where my graph goes down. Constant, I'll still highlight it, but we've dealt with the whole graph, so there is no constant. We still have to write none, identify, but we can see, oh, we change colors at 1. So you can, if you want, you can follow through with all of that color coding, or you can be, oh, we change colors at 1, so we start with blue from negative infinity because of the arrow to 1, and then we're green from 1 to infinity. Now positive, remember that's above the x-axis. Well, everything is above the x-axis, and we are just going to have negative infinity to infinity. So that means there is no negative because there is nothing below our x-axis. Our x-intercepts, because there is no negative, there is no x-intercepts. But we still have a y-intercept. That is a constant. Our y-intercept is 2. And lastly, this is a minimum at 1, 1. because we are going from blue to green or decreasing to increasing. A minimum, if you're a little confused, a minimum, if you think about like you have to be the minimum age, that is the lowest age, this is the lowest point in that area. A maximum, let me see, this would be a maximum because it is the highest point in that area. You have to be, the maximum height to go on this is blah. You can't exceed it. Okay, so this, we can label it, this is a maximum. And you can see that more in number 2. Okay, so this is the end of the video. Log on to Google Classroom for more information.